OSPF, Open Shortest Path First. I will describe how OSPF forwards packets. There is area 0, the backbone, area 1, and area 2. Router 1 has its links, interface gigabyte 0, gigabyte 1, and gigabyte 2. And OSPF has an LSA, which stands for Link State Advertisement. Each router makes one. Router 1 has 3 interfaces, 3 links, we see here. All these links are stored in a link state database. The link state database is used to calculate the best path to forward a packet to any network. OSPF sends and receives hello messages to the router next to it. Now the routers are neighbors and have become fully adjacent. These are neighbors here and they are fully adjacent. Fully adjacent means that these two routers will share all of their information with each other. Router 1 has a link state database that tells details about the network. Router 1 will see hello messages from Router 2. They compare link state databases. Router 2 will ask for and request updates to get current database information of all the LSAs for that certain area of the network. This area here, area 0. Router 1 will comply and send all the updates that Router 2 needs. Now, Router 1 and Router 2 link state databases are the same. Now, Router 2 can use this information to calculate its best path to forward traffic to anywhere on the network. If a change were to happen in the link state advertisement on Router 1 or another one, the neighboring router will share that information. Then all the routers will be updated in seconds for every link database to match. If there were hundreds or thousands of routers, however, that would be a bit much. The network is broken down into parts called area, like here, area 0, 1, and 2. Instead of every router having to know all the link state advertisements for all the routers of the network, it can hold an LSA on their databases for a particular area. We have area 0, 1, and 2. For example, the LSA on Router 1 does not have to advertise all of the routers on the entire topology. The LSA of Router 1 only needs to be shared with the other routers on area 0. The links on Router 1, the interfaces here, are only to be shared with the routers on area 0. Router 2, 3, and Router 4. So Router 5, 6, 7, and 8 don't ever get a copy of it. Then begs the question, how would Router 1 share its LSA with a router outside of the area? For example, let's say Router 8 needs the LSA of Router 1. Router 1 will share its information with the fully adjacent neighbor here, Router 2, and Router 2 will share information with Router 4, which is an ABR, which stands for the Area Border Router. An area here, right here. It's the middle of both of these areas here. So Router 4 will share with Router 6, and 6 will share with Router 8. The ABRs are the gateway for routers to get information across areas. You typically use OSPF for large networks such as enterprise networks, data centers, and service provider networks, when you want routers to efficiently share routing information and dynamically find the shortest paths for data to travel.